Well, welcome everyone. Good afternoon. Welcome to the Association for Contract Packagers and Manufacturers webinar. Today we're titled Robotics 101, How to Start Automating in a Copack Space. Today's session will show us how the newest technology in robotics can be applied to co-packing applications to assist needs for higher levels of automation. Today we have two experts who will walk us through what will be an interesting and informative session on the future of automation in this industry. I'm Ron Puvak, the Executive Director of the Contract Packaging Association, and today I'll be your moderator. Meredith, can we have the first slide, please? Just a quick short overview about CPA. We've been promoting the welfare of our members and its industry exposure since 1992. Our members make up the world's leading contract packagers and manufacturers, perform all types of manufacturing packaging functions for brands and CPGs. The Contract Packaging serves as the connection point for the industry through continuing education, market knowledge, customer relationships. One of the key components of our mission is education. Next slide, Meredith. Today's session is more about education and how our ongoing commitment to this. Next slide, Meredith. And this is a kind of example of our four pillars: industry exposure, networking, education, and of course our very popular RFQ system. Also, I want to remind you of our annual event, which is rapidly approaching, called Engage, the Contract Packaging and Manufacturing Experience. It will occur on March 1st through the 3rd in Clearwater Beach, Florida. There's more information and details on our website, so please look forward to that. Can you advance to the next slide, Ashley, or Meredith? Okay, before we begin, there's a few housekeeping items. All attendees are in mute. At the end of today's session, a brief survey will come your way. Please provide us with your feedback. The entire webinar is being recorded. Within 24 hours, an email will provide you the link to the recorded session. There's also going to be a Q&A session at the end of the presentation, as well as there will be pauses throughout the presentation. If you have a question, please use the question function on your screen, and we will get to all the questions that we get today as best we can. So let's get started. Today's topic will be delivered by CEO and founder of Southie Autonomy, Rahul Chapakati, and the head of business development, Meredith Owen. Rahul has over 15 years of deep robotics expertise leading technical and business teams. His work has transformed how humans and robots work together, breaking down the barriers to using complex robotic systems and empowering people to use robots. Meredith builds partnerships with contract packaging, manufacturing, and logistics companies to drive adoption of robotic solutions to augment traditional manual operations. Meredith, I'd like to turn it over to you. Please get us started.
Thanks, Ron. All right, welcome to Robotics 101 webinar hosted by CPA and Southie Autonomy. We're excited to have you all with us today. All right, so Ron gave very nice intros for both Rahul and myself. So we'll be running the webinar with y'all today. I just wanted to kind of give a quick overview of who we are at Southie Autonomy and kind of how the company was founded. So really our goal at Southie is to be able to break down barriers to using robots today. Robots can be not as easy as they should be, and frankly can be a huge headache sometimes unless you are a trained robotics expert. So we partner at Southie, we partner with co-packers to help adapt new robotics technology and make this a very easy and smooth process. And we'll be going through some of the details of what we do and kind of what that process looks like for building a robotic system today. So we also have some expert advisors here who have spent their careers in contract packaging, operations, and logistics. All right, so moving into the agenda for today. Our goal is to first cover kind of some highlighted trends in robotics that exist today and talk about where there's still some gaps, kind of where are all the robots that we've been promised in a sense. Second point, we'll talk about automation and kind of how to start looking at automation, where to start looking at automation, and kind of develop a process for doing this with your team. And the third piece is we're going to use a use case, a variety packing use case, kind of walk through how to start automating. And then the fourth piece here is just some takeaways, tips, and best practices. So to get it started, I'll hand it over to Rahul to start with the trends across robotics.
Thanks, Meredith. So starting off, I'm sure you've heard a lot about automation and robots, and you wish you kind of get involved, but it is a steep hill to climb if you're not coming with a lot of knowledge. So what we're trying to do here is really just explain what the trends are, what are you seeing in robotics, and put a fine point on it, and hopefully that'll help you guys make decisions. One major thing that's happening here is this idea of commoditization of all the hardware that's involved with the robot. Right? If you want to get a robot up and running, it's not just the robot itself, but it's also the stand that it comes on, and the gripper that goes at the end of the robot arm. There's a vision, there's electrical components, there's safety. And what we're really finding nowadays is that those prices are dropping, right? It's robotic hardware is now a commodity, and what's sort of left over that is not a commodity yet and is still very difficult is how to get those pieces of hardware to work in your environment, right? How do you get that robot to do the thing that you want it to do, which is still quite difficult today. You may have also heard the term collaborative robots or cobots. And this is a new class of robots that are meant to be working very closely with people and workers, right? This isn't sort of the cage robot you might find in a welding cell at an automotive factory. These are meant to be working next to people, being driven by people or tasked by people. And so this idea of collaborative robots extends not just to robot arms, but to mobile bases. Can you start using robots that are people friendly? And not just safety wise, but also use wise. And so this has spurred on a lot of technology and a lot of companies. And what we've identified as a greater robotics industry is that we need to get these tools to be much, much easier to use. I mentioned the mobile robots. Those are sometimes also called autonomous mobile robots, or AMRs. It's basically a new class where these robots can navigate the floor by themselves and basically make deliveries within the floor, or move material handling things, do material handling tasks by moving parts from one end of a facility to the other. And so what we have here is the elements of the robot, but as I was alluding to before, is that this is very much driven by how do I get these hardware pieces to now work in any environment. And that's where a lot of the new solutions that you'll see coming out on the market are geared towards that, right? Can you have these robots do more than one thing, right? We'll talk a little bit more about this term within this Industry 4.0 concept called high mix, low volume, right? Can I not look like a car manufacturer and look more like a copacker and still be able to automate, right? The short answer is yes, Southeast here to help, but it's not as clear cut as you'd hope it'd be, but that's what Southie and other companies like us are trying to do. There's this whole notion of low code programming or easier setup and programming, and we'll talk about what that means. But it's a trend that you should sort of keep your eyes perked up about. Either it's called low code or no code, meaning that these are robot systems that are meant to be easier to use. And as I was alluding to, integration is still the barrier, right? It requires hours and hours and hours of expertise to even know not just how to program the robot, but then how to put that robot into an environment where it can operate in the best way possible. And I'll talk a little bit more about what that means. Next slide, please. So robotic trends, if you look at all the possible, tasks out there that you might be able to automate, really only about 10% of those things that are technically automatable, as in the technology is at a point now where you could automate that task. Only about 10% of all those tasks are actually being automated today, right? And that 10% makes up the $28 billion robotics industry just from the hardware side. Right? The systems and integration and software side are almost 3 to 4 times that cost. And so what we're missing is the rest of the 90%, right? And what's really driving that 90% is that they're completely automatable. We should be able to automate them, but they're done manually today. What's driving that is the fact that there is a lot of variability across how often you're doing that thing, right? It really points to this idea of high mix, low volume, meaning that you have lots of different products, different SKUs that you're running through. You're just doing it at smaller volumes than a very large manufacturer would do, right? But the tools that we're developing, the tools that are coming out of the robotics industry should be able to address that problem. And so, the trend here is, hey, robots should be ubiquitous. Every copacker should be able to use it, but we don't have that right this second. Well, why is that, right? And the main barriers here are changeovers, right? We have that high mix, low volume. You're going to do a different product daily or weekly or monthly, and those volumes are going to be low and they're going to change. And the brands that are driving these trends for consumers are actually also, demanding more and more variation in their product. So what we have to be able to do with our robotic systems is handle variability within a process and then across processes, meaning that, I'm going to have some variability in how I'm going to package something that day. The part that I'm going to pack doesn't come exactly to the robot exactly the same way. I don't have these specific feeders for every single little part variation. But then also, I'm not going to run that one process all day, every day for years and years and years. I'm going to run through 30 different SKUs over the course of a month, or maybe it's 10, right? Even if it's just 10, it's still really hard. And so what that means for a robot installation is that in order to automate that type of high mix, low volume types of applications, you're either going to need one in-house expertise to be able to change that robot over a lot. Two, you want to work with an integrator that you trust greatly and that can come in and do that. However, that's not the case today. Integration is quite expensive. Or three, which is work with someone like Southie, where our whole tool set is to make that easier for people to be able to change over on their own with their own in-house folks without having to have that robotics expertise all the time, which is quite expensive to develop and to hire for. So just to lay that out graphically, one of the things that we talk about at high mix, low volume is the number of production runs, right? For any given run that I'm going to do in a process, how much am I going to do that same run for? Is it a month? Is it 3 years? Is it 10 years? And then obviously for each one of those setups, each one of those processes, how much does it actually cost me to set that up? And this is another way of saying how much expertise and tuning do I need in order to do this, right? Hardware is obviously a piece of that cost, but what we'll talk about is that for any given robotic project, the cost is about 20 to 25% hardware and about 75 to 80% integration or non-recurring engineering costs, where you're going to get an integrator or use in-house engineering to actually get that solution up and running. And so in that context, if we sort of do a map of what are the solutions that are out there today, right? Typically, when you think of a robotic cell, you think of, the robot makers themselves. So Fanuc, ABB, Yaskawa, sort of the big three, KUKA. In those situations, you're going to buy that robot, but then you're going to, again, pay 75% more than the robot to get that robot up and running, right? And so traditional robots are sort of up in this upper right-hand corner, where in order to make that cost effective, you need to have a very large volume run, and then you're going to pay a lot of money to also get it to do that very large product run. And we can get that ROI today. We know that exists. We know there's utility there. Very large manufacturers do this. CPG brands, automotive, electronics, they all do this, where they know they're going to run the same thing for 5 years, so they're going to set up a really high volume cell to do that with a bunch of robots. And what we've sort of been hearing about is this next level, collaborative robots that are slightly easier to use. Folks like Ready Robotics or RD Mind, Universal Robots is a big player in this. They've sort of made the robot more accessible to use, but in this instance, you still have to have that robotics expertise, even though they may claim otherwise, in order to get the parts to and from the robot and make sure that robot can operate in a safe way. And so the boundaries are less, right? It's slightly cheaper and you can do slightly less volume runs, but you still need that in-house expertise. So they haven't quite fully solved all the problems. And so what you have here is this really large gap in the lower left-hand corner. Now, what if I want to do really quick runs and I don't want to pay a lot of money every time I want to change that robot to do something else? And that's the sort of low code, no code place that a lot of companies are playing. And for Southie, what we focus on is that really deep lower left-hand corner. Can I run one shift and have the robot do something else on another shift? Next slide, please. And so what we've seen as an evolution, as I was alluding to a little bit earlier, is that the hardware itself is becoming better and better and better. That means the robot arms are becoming cheaper and faster. There's safer, more accessible types of robots. There's grippers, kind of robot hands, and vision systems that are also becoming more accessible, more affordable. That price is lowering. But what we're seeing is that what's not being lowered appropriately is the integration cost and effort and complexity to get any of these robots up and running. And so this is an important part when you start thinking about, hey, do I want to get a robot into my system, into my processes and into my facilities? How am I going to get that integration task to be done? The robots are there, you can buy them. There's a fixed cost, but that cost is going down every single day. 5 years ago, 10 years ago, most robots were closer to $100,000. Now they're closer to $20,000 to $30,000. And that's going to even go further down. The robots coming into the market that are industrial grade, that are more like $10,000. And those are starting to come out into the market now. And so when we're going to talk about robotics, and basically for most of the rest of the talk, what we're going to focus on is this integration piece. How do I get this hardware to actually do the task that I want it to do? And so we have a few options. The first is the traditional integrator route. You're going to hire a third party with trained experts. They'll come in, assess your process, make some recommendations for what that robot process should be, and then do the integration for that. However, since that is integration heavy, a lot of that cost is going to be their time to make sure that your process is exactly spec'd in a way that's friendly to a robot, right? And the part's going to come exactly to the robot in the same exact way every single time with no variation. And then can I place it into a pack or whatever we're going to be placing into a pallet with specific within specific boundaries of, is it plus or minus 1 meter or plus or minus 2 millimeters? How close can I get that part to be presented to the robot the same exact way? And the more precise you have to be, the more expensive the cell will get. There's ways to mitigate that with vision, but then again, now you need a computer vision expert to maintain that process. And lighting and all sorts of other factors will vary. The temperature will vary how well a computer vision solution will work. So traditional integrators can get very expensive very, very quickly. There's a lot of integrators that won't get out of bed for less than $1 million. And so if you have a task, that's going to cost less than that, if you have one particular station with one worker or two workers in there, is that going to provide you with ROI? Probably not. And so there's a whole set of other tools that are out there that you'll either, if you have in-house engineering, you can start using that and training them up on these what we call low-code type of solutions where it's slightly easier, but you still have to know about robotics. You still have to understand how robots should move and how to bring the parts to and from the robot. There's things like waypoints and drag and drop. Folks like Ready Robotics have a graphical programming system. So if you have folks that are programming savvy, but just want something a little bit easier, that's a great solution. But that's not going to allow you to skip the steps of making sure that the process is well formulated for a robot to go into. And then there's folks like us where we want to come into your facility and say, listen, our robots are smart enough to figure out a lot of this process variability stuff, and they're easy enough for line workers, maintenance workers to change over and do different things with. And so there's a scale of solutions out there that are available, and they're really tied to how much volume you have. If you're going to do the same thing over and over again for years, you can go a little bit more the traditional integrator route. If you are doing different stuff on a daily or weekly basis, you're going to have to go with something more like what we're offering, where it's that really easy changeover and low deployment complexity. Next slide, please. And I'll pass this over to Meredith.
Thanks, Rahul. So I'll pause here just in case we have any questions, or if anyone, wants to make a comment in the chat or something that, have you experienced these things that Rahul was talking about in terms of, you've done some research in robotics, and, has this come up as some of these trends? Have you seen kind of companies like Universal Robots or others where they kind of teach this waypoint kind of drag and drop method for less code or no code, kind of help reduce some of that integration process? So I'll just do a quick pause if there's any questions. If not, I can keep moving.
I think, Meredith, there is a question that popped up. You mentioned a shift or 1 day's worth of production. Is that kind of the checkpoint for this? Is it 1 day's worth of production and you can probably justify these things or not?
Yeah, that's a great question, Ron. It kind of depends on the robotic solution that you're looking at, right? I can speak from a Southie perspective, is that we have had customers that run 1 shift and have seen return, kind of based on our model, which I'll talk a little bit more in a couple slides here. But I would say, Rahul mentioned the traditional integrators. They'll typically be looking for more than 1 shift to find that return because the cost is so high, right? They're looking for kind of higher repeatability, higher volume to see return. In terms of the less code, no code methods, there's kind of that in-between ground. It just depends on who you're working with and what solution they're providing.
Yeah, and to add to that, if you're going to look at a traditional robotic solution, you're going to have that one task basically do it for a year at least. If you're going to go through traditional integrators, the amount of changeover that's available is quite low. If you're going to go with a collaborative robot type of solution and you have the in-house expertise to reprogram that, you can maybe go 3 to 6 months and do the same task. And this is sort of the gap that we as Southie have seen in the market is that if you want to change over on a daily or weekly basis, that is not really available to people that don't have in-house expertise in engineering and robotics. And so our solution is to provide that ability for co-packers to do that in-house without having to hire outside engineers or hire a third-party integrator that is going to be quite expensive.
Great, thank you.
All right. So let's move on to the next section here. So next section, we're going to talk about kind of how to start automating, and I'll be using our variety pack use case as an example of how we walk through that process. And we'll have a few points here on why this was a good case for us to start with. So to begin, so we need to start incorporating automation. We have a lot of challenges with labor in the market, and we can use robots to help offset some of those challenges. But how do we start? So typically, what we look at first is making sure we're aligned with the business team and the operations team, and making sure that you see kind of alignment across the company on your goals for what you want to achieve with automation and where you want to achieve that return. So success of a total automation project does require buy-in across teams. And at Southie, we recommend having point people for the business end, the ops end, and the maintenance. So at Southie, when we help facilitate these discussions with our partners, we do this early on in initial project discussions. And why is this important to have everyone in the room? Well, we want to make sure that the goals align for each area of the business, right? And that we can drive towards meeting those goals through our design and automation and like where we pick to start automating. So for the variety pack project, for example, we had the business team thinking from more of a strategic perspective. They're thinking about, we need to adopt automation for our customers. Our customers want to see us innovate with technology, right? Or we have kind of board or leadership kind of pushing for automation as well. So kind of business mindset really always seems to come from that kind of what's our cost return, what's our bottom line, kind of how we can influence the external partnerships. And then you have this operations perspective, which they'll come in and kind of think about how will this help us run better on a day-to-day basis. So how does this fit into our current process? Is this something that we're going to have to change and make a whole new line for, or change around the structure in the warehouse? What does that look like? So kind of having those two viewpoints in the discussion at the same time really helps speed along the cycle for choosing where to start automating. And so that's why we like to have everyone initially in the room to make sure we're all aligned before we move forward. So the next step.
I was just going to add, you're always going to look for your biggest bang for the buck. Are there stations where, there's five roles that look alike, and if you can get one robot or 5 robots in there, it offsets 5 people or 5 people's worth of throughput, right? Or are you looking for more of end of line type processes where the task is a little bit more constrained, and you can put a robot in there, but then scaling that process within the rest of your facility might be a little bit trickier because there's not as many roles. So that's something to think about.
Yeah, great point, Rahul. All right, so the next step, once we kind of align business and operational goals, second piece here is to identify where to start, identify the application for what you want to automate. So this can be tricky, you have to kind of drive back to your goals, what makes most sense for the goals that you set. And so then what areas in the warehouse, if we were to automate, would give us the best return? And can we utilize the robot for 1, 2, 3 shifts and some other factors that we'll talk about? So another thing is to make sure you're balancing this return with the robot capabilities today. So if the application you want to automate is too complex for the technology that's available, it could require a lot of engineering hours. And this could be a long time until you get the robot on the floor. Like, it might be possible, but it's just going to take a long time to actually see return. In order to assess the complexity of the application you want to automate, we do recommend consulting with an automation or robotics engineering expert. At Southie, this is something we do to help our customers and our partners to spec out the best place to start. But you might have someone in-house that's kind of an automation or robotics expert. We really recommend having that person in the room to discuss where the best places would be to start. For the variety pack use case, for example, we looked at some factors like the volume of the task, right? We looked at the number of shifts that the variety pack is running on the line as well. So in this case, we were able to see return on a 1-shift operation. but it was not the only product that's been running on that line. So there are other products that they do run on that line, and they were still able to see returns specifically just for the robot packing cans. Some other points we considered is that this variety pack application required a high number of workers on the line. So there was a lot of people manually packing on the line to be able to hit those daily production goals. And so this was a good place to help offload some of those workers by using a robot. And then a third point here to consider is that if you're running the application for multiple shifts, you do tend to see return much easier for a robotic solution. In this case, it was a one-shift operation, but just to Ron's earlier question, for other robotic solutions, usually looking at 2 or more shifts are better for automation, but it kind of depends on the application that you're looking at.
Yeah, and Meredith mentioned complexity. What does that mean? So a lot of this is what I alluded to earlier too, which is how are the parts getting to and from the robot, right? In this particular beverage variety packing case, it was pretty consistently a pack of 24 cans coming in trays down roller conveyors and being placed into trays on an active conveyor. So what that means is that overall the process isn't super variable. You're not getting the cans coming in, meters apart, but there is variation on how the cans are coming to and going to be placed into the trays onto the conveyor belt. And so in this particular case, you have 2 solutions. You can mechanically constrain how the cans are coming to the robot very, very specifically, and then you can sort of have the robot work blindly, right? It's just without any vision or seeing, it'll just go to the same exact location and pick. And if there's any variation in the cans, you might miss the cans, right? And so that's a complexity you have to worry about. Whereas in what we were able to do with this particular case is put in 3D vision that's very, very flexible. So it could tell where the cans are shifted and how much they've shifted and adjust its motion so that it can place it into the trays, which are also being moved on a conveyor. So there's a lot of variability in there. We're able to simplify this task using our AI and autonomy tools to make this possible. But when you're looking at more traditional solutions, that type of variability is going to weigh in heavily and drive cost.
Yeah, and that's a very good point. That's why it's important to have these robotics engineering or process engineering experts to kind of understand, how the parts are getting to the robot and how they're moving away from the robot. It's not as simple as just sourcing a robot arm itself, right? There's a lot of more components that go into it, which we'll touch on in a couple of slides here as well. So the next slide here, I just drafted up a quick checklist for kind of operations and business. These are some topics that we consider when looking at robots from, through an operations lens. So you have just kind of rate and speed of the robot. What's the rate and speed of your current conveyor, and kind of what rate and speed does the robot need to meet those speeds and those volume goals? Kind of the time that's needed for changeovers, how often are you changing over on one line or another line, etc. What the variation is the process, we touched on that a bit. Think about safety, how much space footprint, how much space that the robot's going to be taking up in the warehouse, and then who's going to be responsible for maintaining and repairing that robot. From the business end, some things to think about. Looking at the robot arm costs, other hardware that might go into the cell. So do you need to buy new conveyors or tables or cameras and that sort of thing. You're looking on integration costs. You're looking at kind of the cost structure of how that's presented. So are you being quoted from a CapEx end, or is this going to be an OpEx cost? What we're seeing today, some new trends on the market, is this robot as a service model. So that is typically a monthly charge for like a subscription service for a robot use. And so it's just something to think about in terms of how that's structured. And the last piece here would just be other equipment investment that you might need. All right, so we've aligned the business operational goals. We've identified the application. So the third step here is to start designing, speccing, and building the robot. So there are many pieces that go into this kind of design, spec, build process, and we're going to dive into that in just a few more slides. But I wanted to talk about kind of from a high level, some of the options that are available to do this today. So there is the option to do everything in-house. We do recommend having an automation or robotics expert on hand to be able to do this, but there are a lot of great robotics hardware available today and different components where you can source off the shelf and you can kind of put them together to make a full robotic solution, but just making sure you have the expertise in-house to do so. The second point here is to outsource to a traditional integrator. So traditionally, the robots have been integrated with an integrator will redesign a process to fit around a robot and then create a custom program for the robot to do the same task over and over again. So this can be more highly expensive, it can be time consuming, and plus every time you need to do a changeover, you'll need to call that integrator and have them, reprogram the robot to be able to change over that task. Lastly, you could partner with a company like us where we make this much more flexible than traditional robotic solutions. So instead of having to create a new process around the robot, you can put a robot right into the current process with very minimal changes. So this just means that the deployment time for our partners is significantly less than other robot solutions available today. All right, so I'll pause there for some more questions or any thoughts. I'd like to kind of put it out there, what automation projects are you working on today? And if there's any specific, implementation questions, or just gonna pause here.
And the caveat here is that if you're not working on projects, why is that? Is it because is it a technical issue, or is it just you having trouble identifying the right task for that? We'd love to hear the challenges in automation. And feel free to either use this or put questions in the prompt.
I think you guys can go ahead and go on. We've got some other questions coming, not pertaining to the automation projects, but okay.
Great. All right, so then the next section here, I wanted to jump into a little more detail of that design, spec, install process. What does that look like? So on a high level, just to start, what are the components that make up a robotic solution? So here's a model of that variety pack example robot cell, and some pieces that we have in this that are off-the-shelf components are the end effector, the robot arm itself, you have a camera vision component, you have this robot stand and mount, and you have kind of the conveyors, and then one last piece here is the safety. So there are quite a few components that go into this cell other than just the robot arm itself, and each of these components, like the end effector specifically, needed to be sourced specifically for picking up cans and placing those in a certain configuration of those cans. There are a lot of different end effectors that you can use on the market today. There's suction, there's like 2-finger grippers, and there's a lot of other different types that you can use on a robot arm.
Yeah, and more of these are becoming commercially available off the shelf, right? So you don't have to spec a specific custom end effector every single time. There's companies like OnRobot and Robotics that have stock grippers that are varied. They can pick up lots of different things. There's also really great something called tool changers by ATI, which is you can have the robot cycle through a lot of different grippers to handle a lot of different types of product. So if you did have a lot of mix even within one process, it's not a deal breaker that you might have to change grippers.
I think this is also a good point to point out to make a note about the safety equipment. So on this robot cell, you can see there's 2 safety scanners, like safety lasers that create like a safety light shield that if you were a person were to enter too closely to the robot, it shuts the robot off completely. And then we do have caging that exists around our robot that's in, around this robot, this variety pack robot, for the other areas that those scanners don't cover. So it is important to make sure you keep that in mind. This is the piece that makes it a collaborative robot. We are using an industrial robot arm for this application, but we're able to make it a collaborative cell by being able to put up that safety equipment in the right places around that robot cell.
Yeah, and what really drives the division between kind of a collaborative robot, a collaborative cell, and an industrial cell is, in a pure collaborative robot setting, the robot's moving very, very slowly, and there's picking up objects that can't hurt people. And so in that case, you can avoid a lot of guarding and a lot of safety equipment. In the collaborative cell, you might be moving faster than is safe for people to be around, but the lasers let you come in and out of the cell, and that'll basically stop the cell and then restart it again when you leave, or slow down the robot. That's considered a collaborative cell. So the robot doesn't necessarily have to be a collaborative robot. You could use an industrial robot in that type of context. And then there's the traditional industrial cells where the robot's just moving super fast. And if you ever want to go in there, you basically have to shut the entire cell down and physically block off that cell. Those are kind of the three general flavors.
Yeah. All right. So I'll kind of move into the steps for setting up a robotic solution. Once you kind of source these different components and have a design, well, I guess first step, understand the process around the robot, and then you want to design and spec that hardware accordingly to what fits in that process. And then the third step here is to be able to source all those different components that we just discussed from vendors and distributors. All right, so once you you've designed the cell, you've sourced the proper components, then it's a matter of being able to assemble and integrate all of that hardware. And then the next step here would be able to integrate the software on top of that hardware. And we alluded to some of those kind of path planning or those different programs, or hire a traditional integrator or work with Southie, to do those pieces. The step 6 here is to install that solution. And then the last step is just to be able to train people how to use it, and then be able to maintain that robot cell as well. So this is a process. This is how we break down our process. We actually work with our partners to do all of these steps of the process. We'll kind of help guide through that process, but if we were to break that down, that's kind of what that looks like. All right, I'm gonna go ahead and move into a video of the Variety Pack robot in production to show you kind of how all of this came together. So go ahead and play this now. So what you see here is an industrial robot arm with those components that we talked about. It's picking up cans and it's placing those into every other tray along the line. You can see workers are working on that line right next to that robot, where they're placing cans directly into the trays, just like the robot is doing. So our goal for this project here is to make sure that we were integrating a robot into the current process versus having to go in and redesign the whole process that exists today. And that's kind of our goal at Southie, is to be able to just kind of make a robot flexible, to be able to work like a human would work in this process without having to do a lot of revamp of that process.
The other key there was to be able to handle that in-process variability like Meredith was talking about, and then in the fact that the cans are going to be slightly off-centered every single time. They're going to be in a slightly different position, as well as those trays coming down the line. But then additionally, if you use our simple app, in order to do a changeover here, you would just describe a different configuration. What if it's an 18 pack and you're only doing 4 cans into it, or you want to place the cans to a different location in the tray? That all can be changed without involving an engineer. You could simply use an app, or our app or our tablet, to describe that task at a really high level. And then our software will figure out how to change the robot movement and basically programming on its own in order to change it. So in order to change the robot over, you don't have to write any programming at all, no code, no logic has to be communicated, just how is the task different than it was earlier on that day or yesterday. And this is something unique to Southie. You won't find at other integrators or other solutions.
Sorry here. All right, so I'll move on to the kind of some takeaways, tips, and best practices that we have to summarize here. So, robotics can be complex, and so we do recommend consulting with experts in the robotic space to help you guide through this process. This does take time, so start now versus later. There are a lot of discussions in terms of aligning the business operational goals and then picking where to start with automation before you even just start putting a robot in there. So making sure you're starting that process as soon as you can kind of help speed up that process. So then robots often require, or often if you're working with a traditional integrator, requires changes to your current production processes. So just be aware of that. Changeovers can be very challenging and expensive. And then, non-continuous processes are a challenge for robots. So, if you do have line stops that happen throughout a shift, that can be very challenging for robots to be able to handle. So keeping in mind how that process flows is important when speccing and designing your robot cell. And just some tips of kind of partnering with Southie through this process, what that would look like, right? We are trained robotics experts. We're able to help guide the process, which leads to faster results. We try to do no or minimal changes to your current process. Using our AI, we can do changeovers in minutes. And then we can handle kind of more of that variability in the process, that non-continuous process, right? If there's line stops, if there's changeovers, something about our technology helps robots be able to handle that better.
Yeah, and we are focused on copack. So our service comes with both the robotic integration and services, but also operational consulting to make sure that the robot fits within and value.
All right.
All right, Meredith.
So thank you for listening. Any questions from Ron?
Yeah. All right, Meredith, Rahul, thank you so much. Do have some questions coming in, so get ready. What specific industries have you seen the most acceptance to this technology? Can you give us any examples?
Yeah, so I alluded to a little bit earlier too. So obviously automotive has adopted robotics far and wide, but when you go to an automotive facility, you'll still see a lot of people doing a lot of work. And those are typically going to be the tasks that are very, very dexterous, or they're going to be tasks that are small in volume, right? You basically do one task and do another one and kind of switch over really, really quickly. The same thing goes for electronics as well as the consumer goods product area. So, the big brands that probably a lot of you guys work with, CPG, has a very large automation presence. That's the nature of the question.
Sure. Well, I think let's pull it closer to the command copack. Yeah. In a command copack arena, where have you seen maybe the early adoption of this technology seems to make sense? Where have you seen most of this type of industry or these subsegments in this industry adopt this?
Yeah, so you'll see
from
a lot
product standpoint.
Yes, end of line operations are typically sort of a good place to start. So palletization,
okay.
And obviously some wrapping, some picking, some placing is always helping. Also feeding for machines. So if you're feeding a wrapping machine, that's a great place to also look. Again, you'll just have to be cognizant of how those parts come to and from the process. But
sure.
machines is a big one.
We are seeing a lot of interest. We chose that variety pack use case because we are seeing a lot of interest in that variety pack. I think that the copacks that we've talked to, a lot of their customers are seeing a lot of spike in variety pack. So, if you have a lot of people on that line that are manually packing objects into trays or into boxes, that's definitely something that you could offload with a robot.
Yeah,
that's a great point. I think that's probably where they were going. Is it something like that? So, okay. Just from a general sense, you go down this path, especially the solution you guys are proposing, how much level of expertise, in-house expertise or training do I have to have? What kind of level of people, what are you requiring, my folks to be when you're done?
I think that's really driven by what type of expertise you already have in-house and what route you want to go. If you want to go the in-house route, you're going to need an automation expert that's created robotic cells before and tested them and delivered them to factory standards. And then there's sort of the, do you want to work with an integrator? And in that sense, you just need to have someone that understands your process and can communicate that process to an automation engineer, and also be able to work with maintenance or whoever's running the machinery in that process. And you may have to change things around and run additional machines to help feed the robot. When you're working with someone like Southie, we're going to come and consult for every piece of that, from the operation side to the robot integration side to the hardware delivery and training. Did that answer the question?
Well, I think let's look at the solution is installed, it's operating. So what level of residual expertise do I have to have in house? You know, obviously I can call Southie to help me out, but if on an ongoing day-to-day basis, you know, do I need electronic engineer or somebody just competent in electromechanical systems?
Yeah. So again, so if you're going with a integrator or an in-house solution that doesn't include Southie's AI, and you've just sort of programmed a robot as it comes, you will need someone in-house that can debug and understand error codes that are coming from the robot on a daily basis, or if there's something that isn't quite working, they understand the machinery that feeds the robot and what needs to be adjusted to get that robot working. So you will need an advanced user in-house to deal with the robot on a daily basis. If you're working with Southie, you don't. That our solution is geared towards maintenance folks, line workers, line supervisors, people that are dealing with conveyor belts and wrappers, right? And that's the level of technical skill you need to work with one of our robots.
So what you're saying is today, if I have a trained electronics, you know, mechanical guy, he can handle this solution once you guys get done, right? That's what you're saying.
With Southie's solution, yes.
Yes.
Yeah,
okay,
we see that, you know, the maintenance workers that kind of maintain the machines, like the wrappers, the sealers, they maintain the robots, you know, with just a little bit of training from our end, and that's not a huge lift for them. And then a couple of line workers have been trained to operate the robot. So we make it as easy as we can.
Okay. A question came through about maintenance and ongoing. How long do you expect a robotic solution to operate without a major update, upgrade, rebuild? You know, what's the life expectancy of the systems you guys are installing? What do you know?
Yeah, for example, we love to work with Mitsubishi Electric robots. They come with a 3-year warranty. That's actually not standard. Most robots have a much smaller warranty. It's typically a year. But there will be continual maintenance that has to happen. You do have to do a little bit of preventive maintenance, but that's over years. And it also depends on how many cycles you're running the robot through. If you're running, you know, all 3 shifts all day, every day, you're going to want to do preventive maintenance at least once a year. And if you're running smaller runs, you know, 1 shift over that course of that year and not every single day, then you can get away with 1 to 2 years. But it's mostly going to be monitoring the motors, making sure that the system is clean, the robot's clean, there's nothing kind of building up there if there's any residual in your environment. But a typical robot should last you 5 to 10 years.
Okay, that's good. Okay. Does this technology have a different ROI than traditional machinery?
It does, yeah. So Southie's solution, what we're delivering is, we kind of mentioned this before, the robots as a service. So what we're offering is the ability to get ROI on a monthly basis. So there is no upfront cost. You pay monthly, and that monthly will be probably less than you're paying for a worker today on 1 shift. So if you're running multiple shifts, there's immediate ROI on a monthly basis.
Okay. You had a 25-75% rule about hardware integration costs. Then you talked about a 10% or a $10,000 robotic solution, you know, robot hardware. Does that still carry the same kind of 75% rider on top of it?
The 10K probably won't, right? You're still going to be looking at 75K for integration for even the simplest robot with traditional integrators, and even then, they may not want to look at that type of cell. If it's under 100K, there's not a lot of integrators that will look at that type of work. That's sort of where Southie and folks like us come into play, where, you know, that's right in our alley. That's our target sort of cost structure, is within that 100 to 120, you know, over a contract life, right? So it's a monthly fee in the thousands. If that kind of makes sense.
Yeah, I think it does. No, that does. It does. So, from your experience, what are some of the initial inquiries you guys get? You know, why do people come to you? What are they asking for? You know, granted, you have a process, but you know, what's that initial request or inquiry about? Can you give us some insight there?
I think a common thing is what we hear. What we hear a lot is just like labor challenges. It's just so challenging. You know, we just need an alternative. So can we use robots for this? You know, what does that look like? I'd say that's probably the biggest one. Rahul, do you have some other thoughts?
Yeah, that's number one is I can't find the labor to do the work that I need to do. And so I want to look at automation, but when I look at traditional automation solutions, they're either this really, really large CapEx expenditure that doesn't make sense for me, and I don't have the volume that it would take to get ROI in a traditional setup. What can I do in between? And that's really where Southie's main differentiator and where we fit nicely is that we allow folks to automate at smaller volume levels and in batches. That's the number one people come to us, and that can include things like variety packs, palletization, depalletization, when there's lots of variation between what the pallet being built is, feeding lines, putting trays on the conveyor belt like you saw in that particular video. There's a person doing that, but those are the types of things that Southie can do well. It's these things where you're simply picking and placing, and you want to offset labor from a temp worker, right? So these are atomized tasks that have been simplified so that temp workers can get in and out of there quickly, and those are really well set up for robots.
And something else too, the copack, let's speak specifically beverage, right? Oh, we change over from cans to bottles to cartons, maybe every day. Like maybe we'll do cans one day and bottles another and cartons the next, and there's just so much changeover. And we've looked at robots before, but to be able to do those changeovers is really expensive, or it's, you have to get these bottles or these cans specifically to the robot in just the right place, to be able to automate it. And it just hasn't made sense before. But I think what we're seeing with the robotics technology today is that it makes, with what we do at Southie, for instance, we make changeovers very, very quick, very, very easy, so that the same robot can pick up cans, can pick up bottles, can pick up cartons. And so therefore you're able to get a much better return because you have a robot that can be used for multi-purposes, if you will.
Okay. So good. And I think the next question I'm getting is probably ties right into this. Your end effect tooling or costs, how variable is that, with the setup, with your doing? I mean, how many different tools will you need? You mentioned bottles and cans and cartons. Is that 3 different end effect tooling, or more universal? Help us out understand those costs or those challenges.
Yeah, I hate to use this answer, but it depends, right? But if you're looking to pick up one item at a time, there's lots of off-the-shelf components that are fairly affordable. Maybe $1,000, $2,000 over the life of that sort of task, right? And you can use that gripper for years and years. And so that's at the 2K level, 5K level at the most, between 2 to 5K. If you're going to go custom end effector because you want to pick up 10 of a specific item all the time, that's when the price starts going up a little bit. It's going to be 5 to 10K, depending on what that is. But the goal at Southie is always to create end effectors that are reusable across different types of product types. And okay. This isn't supporting that, but it's still there.
Yeah, one thing to consider when you're thinking about grippers and end effectors is payload, right? Because the grippers are going to change depending on the payload of the objects that you're picking up. So if you're picking up only 4 cans versus 8 cans, that's a different weight difference. So, and there are ways to design the grippers to be able to one gripper to be able to accommodate both. But there, if you have to change over end effectors, there are pretty easy ways to be able to do that as well.
Okay, staying on that line about the end effectors, with your business model or robotics as a service, are the end effectors part of that business as a service, or is it typically run separately and like you own that no matter what?
Yeah, typically when you engage us, it'll the first time you do, it'll come with a set of end effectors. Then as you expand the applications that you use that cell for, there's typically an added cost for buying those end effectors off the shelf. But again, they're fairly low cost and they are reusable.
Okay. All right. So as you've gone through this process several times, a lot of times, what are some of the hurdles that you have typically found when you start getting into this process? Whether it's the business hurdle, or the operations hurdle, the maintenance hurdle, just set an expectation of people, what can they expect as they start down this process?
Yeah,
I can start with a thought on the operations end. I think with copack, and there's some non-continuous, maybe some line stops that happen in there that we weren't expecting when we first started working with copack. So I think that's something that we've made a solution for. That's pretty easy for our robots to handle, but just something to consider, right? Usually you're thinking about robots doing the same thing over and over again, and so having to stop on a second's notice for a robot
Mm-hmm.
is challenging. So making sure you're aware of kind of those pieces in your process that humans can handle very well, workers can handle, without even thinking about it. But robots need some way to understand to be able to do those things.
Yeah, and relatedly, kind of if I could pull that up a little bit further, is being able to measure and understand your current process with people. Not just what's my output. It's not just how many pallets am I bringing to the workflow and how many pallets come out. It's a little bit more fine grained. How fast is each station running? What is the throughput on a per person basis? You kind of have to have an idea on how to measure these things before you put the robot in, because if you can't measure that before, it'll be really difficult for you to measure, well, how much has the robot improved my process, especially if this is your first time using a robot or first time automating. You're really going to want to spend a little bit more time up front saying, how am I going to measure performance? How do I know if this is that solution? That's really, really important up front. And I know in copack, there's a lot of dynamic things happening, and so sometimes it's not easy to go do that exercise. Really important.
There are specific pieces of the robot process that are kind of most challenging. So I have a lot of discussions with people about placement of objects, right? So you can pick it up from the same area every time, but then where to place it and how to place it exactly. And if you have trays that are moving along a moving conveyor, the placement can change. So having a way to make sure that the robot can place where you need it every single time tends to be kind of the hardest piece of this problem. Something we handle at Southie, but just in general when thinking about building that robotic solution.
Okay, great. Well, time for one more question you got popping up here. Answer around portability. I mean, what you showed, a lot of the situations look like they were pretty much fixed assets. How portable is the solutions you guys can propose? Moving it from one line to another line to a place, one location, another location.
Yeah, our solution is built for that. So we want to be able to have that robot be moved. When it's operating, it's fixed, like you saw in that beverage cell, but actually there's wheels on the stand for that robot. And so what we could do is simply pull up 4 bolts from the floor, and you can move it to another station and bolt it there. And then there's 2 camera stands that you want to also place in that cell. So in terms of added machinery that is needed for the robot to run, it's extremely minimal compared to a traditional automation solution where you may need a feeder. And if you're going to move that robot to a different location, a different task, you're going to need another feeder that's set up over there. And you need the robot to be very, very finely calibrated with that movement. So traditional automation doesn't lend itself well to moving from task to task to task, which is why we exist and why we created the solution, is to enable folks to be able to do that without having expertise on the floor that's going to then have to repurpose that robot.
So in essence, high degree of portability, be able to move it. Great. Awesome. Well, hey, Meredith, Rahul, thank you so much for the presentation today. I'd like to thank everybody who was on our audience today. Hope you had a good time with it. I know we did. I also want to remind you, don't forget about our annual event called Engage at the Contract Packaging and Manufacturing Experience on March 1st through the 3rd at Clearwater Beach. Hope we'll get to see you there. On behalf of CPA, I want to thank you for attending and have a great day.